things beyond differential privacy. She's thought about game theoretic definitions of privacy. She comes from an information theoretic background, and looking forward to hearing about privacy differentiated markets.
Thank you, Aaron. Slightly different talk from the previous one, but in keeping with the spirit of everything beyond, right? This is a work with my really awesome graduate student who's graduated and is doing really cool work for FICO, it seems, not related to any of this. So I don't want to go here, but I'm going to very briefly mention that let's broadly assume privacy means learning things, letting people infer things that you didn't intend in your interactions with them. Okay? So obviously, blah, blah, blah. We all know this stuff, so I'm going to sort of quickly skip through this. But the only thing I want to point out is a lot of us do work on where we have a data set and perhaps we can learn something statistical from it. And so either the release from the data set while learning the statistics is protected with some notion of privacy, or you want to publish a data set and you have some notions of privacy. So this is something we're very familiar with. We're also somewhat familiar with cases where a data collector collects data in a very distributed manner and provides some privacy guarantees by saying, well, that's some noise, we'll learn statistics and so on. Now I'm going to talk about something very different. I'm going to talk about, is there even a notion of privacy when consumers and retailers interact with each other, and then you get a coupon for some pregnancy-related product just because you're 16 and they figured out you're pregnant even before your parents figured it out. So now how do you even model these kinds of problems and ask the question, is there a way for retailers and consumers to have a notion of privacy, right? So I'm not going to actually talk about how to quantify privacy. I'm going to ask the following question. Well, I wrote a very broad problem, but the question I want to ask is, if there were such a measure of privacy, could retailers differentiate themselves? Okay? So everybody knows this, right? We're all online. And not only are we online using a lot of products, we use a lot of products that are free. And we know what the consequences of that are. I mean, basically, our data is their currency, and they get a lot out of it, right? But what if, and we love it. I think I like free services. Who doesn't? But the moment we figure out, oh, yeah, Google's doing all this stuff, and you go into Facebook, and it keeps putting these sponsored ads at you, they completely figure out everything about you, including your browsing preferences, or every website you went to, at least you're creeped out, if not anything else. At least some people are creeped out. Keep that in mind. Not everybody is creeped out. Some people are creeped out, right? So Google said when they collect their data, they can use something like Rapport. Apple has some version of it. Works in some context. Often, I think at least, I don't know the entire details of their mechanism. Sure, there's an epsilon associated with it, but we don't know what they do, right? So there is no notion of choice in these contexts. So the question I want to ask is, from a somewhat game theoretic viewpoint, can there be a market for privacy differentiated service? Okay. So there's a New York Times article today about op-ed. Should Facebook be broken up? I'm not going to talk about whether there should be a competitor to Facebook that offers different products, because in that context, there's a barrier to entry. I'm going to talk about a setting where there are already two parties, and they offer slightly different services. But their services include a notion of providing you a privacy guarantee. Okay? So as a running example, and no offense since this talk is being recorded, to any of these service companies, just as a simple toy model, we'll talk about two service providers. We'll name one of them Google, it's just a cute little name, and the other one of them DuckDuckGo, because it just seems like another interesting name, right? And so when they offer their services, which could be, for example, web browsing or search engine, they could say, we have a very high guarantee on searches, very good results. And they could also say, but we use your data only so much, and that corresponds to a certain privacy measure that we give, right? So these two service providers have their notions of search quality of service, and a privacy measure. So the question is, how should the consumer pick? And the question is, if, say, DuckDuckGo is the company that provides you some better privacy guarantees, how many users are going to actually take DuckDuckGo's service? So right off the bat, if DuckDuckGo does a much better, is much better at providing you very good searches and provides you very good privacy guarantees, that's it. There's no market here, there's no game here, it's all done. So that's not the situation. We're going to, and so we'll formalize this. So here's your problem. There's a whole universe of consumers. They all have heterogeneous choices in privacy. And there are these two service providers that pick particular values out of these heterogeneous choices, right? I don't know how to do this without explicitly parameterizing a few things. And you may not like it, but I'm going to do it this way. So bear with me. And there's a bunch of parameters starting from here. And this is important. We're going to capture some notion of consumers' heterogeneity in privacy choices. Okay? I have to explicitly model cost and revenue so I can talk about profit. Okay? So there's these two notions. And there is a notion where you have to map things. There's privacy and there's QoS. How can I compare them? So I have to map privacy to, say, some notion of quality or QoS. And that's where the consumer's valuation of privacy comes. Okay? None of us know how to compute these things or how to put numbers on them, but we'll go along in this mathematical model. So obviously, I'm not the first one to do this. There have been others. They've looked at, in the monopoly case of differentiating, they've looked at the non-free markets, like price-based competitions online, and they've also looked at a duopoly case, like the two service providers, but with very specific privacy guarantees. So what we're going to do is the free markets, so there's no price. Okay? So the differentiator is both the quality of service and the privacy preference, that the privacy guarantee that the service provider gives you. And I'm going to allow consumers' heterogeneity in privacy choices to be just infinite. Okay? The whole range. So immediately, the one thing that comes about, it's a non-cooperative game, right? If they cooperated, that's not really a market in that sense. Okay. So if you look at rapport, I think picks epsilon equals what, 0.1, 0.05? I think so. I don't know at least. So the point is there's a possibility of picking different values, right? So one may assume that each one of these service providers picks a particular value of epsilon. Epsilon could be over a very large value. I'm not assuming they're doing differentiate private or any privacy or anything like that, but that's an example. Okay? So we're going to assume that consumers also have heterogeneity in choices, and the service providers pick a particular point in that to operate. Okay? So there's a very classic model in economics, which is called the hoteling model. Well, hoteling also happens to be a signal processing person. And it's this question. If you had two retailers, two retailers, and they were offering the same product, but they had a choice of how to price it and where to locate themselves. How would they do that? Okay. And this is a very classical model. There have been other models, so we thought we'll start here. And in our case, there's no pricing. So as I already told you, we're going to differentiate by QoS and privacy risks. Okay. So right off the bat, and I've already told you this, there's a notion of quantifiable QoS and quantifiable privacy risks. Okay. So even if there is no notion of a price, there is a cost for every service provider to do these kinds of things. So a service provider can generate revenue from the data that they collect. Okay? Unless there's that notion of profit, I think there's no game here. Okay. So the consumers, ultimately, when a service provider puts out that I'm going to pick this kind of quality of service and this privacy risk, consumers get to choose between the two options. So the consumer is actually the person that couples the two games, the two parties. Okay? All right. Okay, now that we've done that, so we have two rational parties, which means they really want to maximize their profit. Okay? So I've told you these now. A little bit of math. We're going to use the V's for QoS, or the news as you call them, and the epsilons, because we all like epsilon, right? Epsilon for privacy risk. Okay. And I already told you this. If DuckDuckGo gives me a better privacy guarantees, obviously its quality of service better be less. Otherwise, there's no game here. So even more simplifications, some kinds of cost models. Simple linear cost model in terms of breaking up the cost. None of this makes any sense, perhaps, but we're going to start somewhere. Okay, so I'm going to assume the cost depends on only these two things, QoS and privacy. And I'm going to break it up into two parts, where I say that there's a cost for either Google or DuckDuckGo to give you some quality of service guarantees. And there's also a cost to giving you privacy guarantees. You know, I have to implement a rapport, I have to come up with good PageRank algorithms, and so on and so forth. So there's a cost to doing both things, right? And the revenue can also be broken up into two parts. There's a revenue from a data stream that's, you know, I use your private information, I can get revenue because I can have all these people advertise to you directly, and every time they use my platform to do it, I get money off of it, right? And there can also be an independent kind of revenue, which is somewhat hard to describe, but you know what, I don't use your data, but still, just by being there, I have people coming to my search, using my search engine, I can get some revenue. Let's pretend that it's possible. Now, how do I model the consumer-retailer interaction? This is how I'm going to model it. Okay, so.
Does the revenue depend on the number of people choosing the service?
No, this is, so that'll come in. Okay. That'll come in a minute. This is sort of like per consumer. Okay. So here's the hoteling model. The hoteling model says, obviously, you can space yourself anywhere in the universe, and I'm going to normalize the distance between two providers to be on the unit line. Sort of a linear, simple, one-dimensional model. So in our context, that would be DuckDuckGo sitting here and Google sitting here, because they provide two different privacy measures, risks. And for our understanding, the smaller the epsilon, the higher the privacy guarantees are being given. Okay? All right. Consumers can be anywhere on this range, and really, there's really a big range. I'm just mapping that entire range to 0, 1. So the end of this range is some epsilon bar. Okay. A consumer is sitting somewhere in between, and a consumer gets to choose. In the classical hoteling model, the consumer has a transportation cost to each one of these retailers. And it also then picks the one that gives the best price. So the consumer maximizes utility in that way, and these folks have to maximize their profit. Here, and their transportation cost is sort of is symmetric. Here, there's somewhat of an asymmetry. Maybe I'm just like, maybe I'm a consumer. So if I was sitting somewhere here, I would have a very strong, I'd be very, very privacy aware. If I was sitting somewhere here, I really don't care about privacy. And if I'm somewhere in the middle, I'm worried a little bit about privacy. Right? So if DuckDuckGo gives me a privacy guarantee that's even lower than mine, I actually gain by using DuckDuckGo in terms of privacy. I may not gain from the QoS. So the utility of a consumer is going to come from both the QoS and the privacy. That's all I'm trying to do. So this is where it is asymmetric and not symmetric like the classical hoteling model.
Yeah, but there is an issue with the utility of a consumer is that the epsilons imply a worst case kind of privacy loss, but not the typical kind of privacy loss. So I'm not sure I can use it to directly compute the user's utility.
Yeah, but you're just assuming epsilon is coming from DP. I don't care what epsilon is coming from.
In general, no matter how you measure privacy, this would be a measure, likely be a measure of like,
or population level.
Like a worst case or
We don't know what
So
epsilon.
if I understand correctly, you're saying the issue is that users may not even have the same ranking of the privacy guarantee.
That's also correct.
That is being captured here. We'll get to that in a minute. So the user can have any value from 0 to epsilon bar. Okay? The user could be sitting anywhere. The user is X. Google and DuckDuckGo are fixing their choices. Let's start the game there. Google and DuckDuckGo are fixing their choices. They're going to look at all the users. So every time there's an interaction with a user, and over all possible users, they have to pick the one. They pick a value at the end of the game as to where they will offer services. But there's a heterogeneity in the users, and that's sort of captured by a random variable that models how users are distributed. Okay, everybody is frowning at me.
So maybe, to Kobe's point, maybe stated differently, is under most mechanisms for preserving privacy and most notions of privacy that I can imagine, different individuals might experience different privacy harms under the same mechanism. and that's being assumed away here.
Yes.
And
Yeah.
I think it's just worth saying that it's being assumed
Okay.
away.
And maybe you're assuming a worst case for every user. Maybe, and that's the
So
same,
then-
I don't know.
So then maybe the terms that go into the utility functions don't quite match up with the experienced harms and preferences.
True. Yeah, I can take, yes. Is that okay? That's just a model assumption. To keep it simple. You're right. I mean, it'll be ideal if Google tailored this to every user. Even the report doesn't do that to the best of my knowledge, but
No, it's
No,
not
that's
Google.
sort of
Like
much of-
a privacy mechanism that is epsilon differentially private, two privacy mechanisms that are epsilon differentially private, could incur very different kind of risks, even if they maximize the use of the individual's privacy and whatever. And in terms of cost to the individual, they could be very different. So the number epsilon, we understand it as a way to, in differential privacy at least, as a way to bound the kind of harm you may have. That does not mean that this is the harm that the user actually experiences.
okay. Yeah, I'm just going to assume it is. That's it.
But like, are you objecting to like any single, it's been defined very generally here, like any single parameter model?
So,
I think also k-anonymity is like that, in a sense it says, tries to capture a maximal kind of harm. I'm not aware of definitions that are not like that.
So I guess any kind of linearization of like this 0 to epsilon bar scale says that, like, assuming that so in particular, like for the same mechanisms, SP1 and SP2, Kobe may rate SP2 as better on like in terms of, you know, disclosure, he may prefer SP2 to SP1, I may prefer SP1 to SP2. Right, so if I understand correctly, what you're saying is that the ranking of the different mechanisms is going to be the same for all users. How much value they assign to like the particular cause, but like there's like one number. You know, the fact that epsilon 2 is bigger than epsilon 1 from my point of view implies that it is also the same from Kobe's point of view. Is that correct?
That is correct. Those absolute values of epsilon 1 and epsilon 2, yes, that is correct. I myself may not care that epsilon 2 is too large because I might be here, but yes, that is correct. I'm going to stick with that for you. Yes.
Yeah, so that sounds great. I'm on board with that. I'm just wondering if you can remind me or clarify the sort of what the user's preference or their type is. So I understand that the service providers are on the epsilon line. Does the user have a type that's on this line? And
The user has a distribution on this line. So users could be uniformly distributed. It could be Gaussian distributed, truncated, Gaussian, whatever you pick your
and so
favorite
if my realization is
CDFI.
X, what does that mean for my preferences or for my utility?
I'm coming to it. in a
Oh,
minute.
it's the, okay, I'm sorry.
I haven't had a chance to do it. So heterogeneous, so I'm actually going to model it with a random variable. That sort of addresses it. So there's a CDFI association, okay? Okay. So in this case, obviously, as I said, I've mapped price to QoS. And I also mentioned this mismatch is no longer symmetric. So if a user was sitting here, because it actually gets, when I put down the utility function, you'll sort of see this. But one thing I want to point out is there always exists a point on this line where what you would call an indifferentiation, where the value from both SPs are the same for any user, for that user, right? Okay. So I've explicitly written something here, and we'll come to that in a minute. So the consumer's total utility is a sum of two parts. One that comes from QoS, and the other that comes from the privacy violation. So I'm going to map the privacy violation to a QoS quantity just by multiplying it by this factor t. Right? So this is the actual value that service provider I provides me in terms of a privacy guarantee. This is the normalized position on the 0-1 line of my choice minus the privacy guarantee that's being given. Right? So that's sort of the gain or the loss I have relative to my preference for this particular service provider. And T is my factor that goes from privacy to, say, QoS. It's how much this consumer values privacy in QoS units. way of mapping it, and it's all linear. It's classic hoteling, it's linear. Okay? All right, so if you look at this, obviously for this consumer sitting here, SP1 is giving it positive utility, whereas SP2 is giving it negative utility, as an example. All right, so here's the utility. The net utility of the consumer is going to be the QoS plus this quantity. I sort of already told you that. All right, so, okay, so standard notation of saying for my strategy, this is the strategy of the other service provider, there's two of them. The way you have a game is really because the profit of every service provider depends on the choices made by the other through the number of users that pick this one or that one. So the profit per user times the total number of users, the fraction of the users, is going to be the revenue minus cost times the fraction is the profit for each service provider. Okay? All right. So there are two assumptions here. We're going to assume that these service providers are rational in the sense that they're not going to offer non-negative QoS. And the problem is this is a parametrized game. So the only place where these parameters make sense, only place where the game makes sense is where these parameters actually allow you to ensure that the market is completely covered. That's important. So what that means is that, it's possible that nobody provides services below a certain epsilon.
Oh,
So we're not going to assume that.
Sorry.
you're gonna assume
You are
that
going
the-
to assume that.
The market will be completely covered by the two service providers. So one service provider will be sitting somewhere here and the other will be sitting somewhere.
and
There
every-
won't be these non-convex regions, union or something like that. Won't work.
Meaning there will be a service provider providing perfect privacy.
There will be a service provider providing any value of privacy over this range, normalized range, yes. They would not abandon any region.
But there's just two. How many service providers?
There's just two. But it is possible to have a solution where they both abandon a certain region, is all I'm saying.
You mean a
We're not
region
going to
of
assume that.
users? Not a region of what they pick, but a region of users who just aren't.
Right. Yes, correct. So think about this. This is really the range of users' preferences, right? So it's possible that they both abandon this share of the users to not provide them any service. It's possible to do that.
I think I'm a little
And
confused
wait, so
about
what's the
this.
assumption? The
I
assumption is that doesn't.
We're not doing that. Yeah. Our assumption is that we're not doing it.
Service providers pick a single point,
Yeah.
or do they pick a region of
They're not picking a region. That's all I'm trying to say in a long way. Maybe I shouldn't have even brought that up, but yes. But it's important to bring it up in the following way that, because there are so many parameters, these parameters will only allow you, there's only certain parameter ranges for which you can get solutions. That's all it's saying. And that will become clear when you do some of the math.
Sorry, can I just chime in one more? I think, just to make sure I understand what you're saying, that it could be that, like, I'm a person where both of these people are providing me, like, negative utility and I stay home. And is this assumption saying there is no such person? Like, everyone would rather go to at least one of these providers? Is that the same as saying the market is covered?
Yes, that is the same as saying that, but it's a little bit more nuanced than that. Maybe it'll become clear when I work out some more of the math for a concrete cost and revenue function. So bear with me for a few moments. Okay, so let's just see how the game is played. So the way you play this, actually, you would set up this game as a sequential game. And so each service provider sort of advertises its QoS and its risk. Every consumer picks the service provider that maximizes it for them. And then the rewards of the service, each service provider computes its rewards. And so the reward is of every service provider is really its profit. And then the rewards of the consumer is the best utility it gets from the two service providers. Okay? So because there's this interaction through the consumer between the two service providers, you can sort of break this up into what's called a sequential game. Okay? So in the first stage, the service providers would sort of announce, this is the privacy risk we're going to go with. Okay? And then based on that privacy risk, so keep in mind there's really sort of only one independent parameter. So based on the privacy risk, they come up with a QoS. Oh, really? Oh, this that multiply by 2? And I can finish. But then in the last stage of the game, the consumer picks the service provider for these particular values. Okay? So when you do these 3-stage games or any sequential game, there's this notion of there's a well-defined solution, and that's this subgame perfect Nash equilibrium. And it's sort of exactly what it means. In each subgame of the sequential game, there's a Nash equilibrium, which means a point at which neither player, service provider, diverges from this choice. Okay? And then the actual equilibrium, so it's a solution that guarantees the Nash equilibrium for each subgame. And one way of calculating this is to actually use what's called backward induction. So you'd start for a fixed value of these two, you'd start for the consumer's choice, then you'd go back and then use the consumer's choice to determine for a fixed value of this what the QoS is, and then you go back and solve for this. Okay. So here's something that is useful to know that we can prove. That is that there's really no subgame perfect Nash equilibrium at which both users offer the same privacy risk. What this means is that if they were both to offer the same privacy risk, one SP can always do better by moving away from that. That means they can get better profits by actually offering either a smaller or a large. Okay, so the only way I can solve this is to assume some more models on the cost and the revenue. So here's what we did. We started with something very simple. We took a linear model on the cost and the revenue. So, and I think I sort of assumed this, right? I assumed that cost is going to be a sum of the cost that comes from QoS and a sum of a cost that comes from providing a privacy guarantee. And I'm sort of writing that out. So for a given QoS, there's some scaling factor that converts it to, say, dollars. And for a given privacy risk that a service provider offers, there's a mapping to QoS, and then there's a mapping to cost. Okay. All right. And for revenue, since I get revenue from using your private data, I can map that into some revenue scale factor. And then this part is where maybe there's a loose correlation with what I would call barrier to entry. Say, for example, Google had an ability to make revenue in many other ways without using all your data directly. That is a differentiator for the two kinds of service providers. Okay, so this is not coming from the private data. It's sort of a non-private gain, that revenue that each service provider could offer.
So this is the revenue they make for each user that selects them or something. Yes, but so the way to look at this revenue is to say that this is the revenue they would make just by being able to perhaps get a lot of people to use their platform, but not from using their data. It's a little hard for me to quantify, but the only thing I wanted to say is that is there a differentiator between them that's independent of users' data? And so they just put a number in there, right? So for every consumer, this you've already seen this. Right? So broadly, there's a lot of parameters here, but to look at this, epsilon goes from 0 to epsilon bar. Okay? Revenue depends on a non-private revenue that they can generate, and from the privacy, what's the revenue? And I'm obviously assuming that these R's and C's are the same for each service provider, which is also an oversimplistic model, but we start somewhere, right? And then there's an operation cost for each service provider, which is also assumed to be the same, just to keep it a level playing field. And those are these. The operation cost of providing you a certain QoS, and the operation cost of giving you a certain privacy guarantee. Right? And the last part is, how much does a consumer value privacy? And that comes from how much do I map a privacy choice to QoS. So there are all these parameters, they sort of come into play in some fashion. So we're going to assume a uniform distribution over the heterogeneity of consumers' choices in privacy. And then you can, so the CDF just becomes directly just a normalized CDF. Okay?
So epsilon I over epsilon. All right. And by epsilon 1 or epsilon 2 is the choice that each one of these service providers is giving. Okay. Over epsilon bar. All right, so there's all these quantities here, so I just want to quickly go to a sort of some cute results. So for this particular model of revenue and cost, what we can say is there actually exists a subgame perfect Nash equilibrium. Okay? And here's what I meant. So the model parameters have to facilitate a competitive market, meaning the model parameters cover the entire range of possibilities. So all consumers can have a choice. That's the assumption we're making. Under the conditions that all consumers can have a choice, and there exist model parameters that facilitate that, there exists a subgame perfect Nash equilibrium. Yes. There's an assumption, and then there are these conditions. And so this is not so important. Here's what's at equilibrium, what are the strategies? So here's DuckDuckGo, and here's Google. And from the math and from this model, it sort of turns out that they sit about 3/4 of your entire range of privacy values apart. Assume epsilon bar is finite. Okay? And so, and then the equilibrium QoS choices is obviously DuckDuckGo gives you a lower QoS than this, and it's related in the following manner. But here are some of the interesting observations, right? If you look at these P's, where was the revenue that each service provider could make, that's independent of using your private data. So if Google had a way to make more revenue than, say, DuckDuckGo, independent of consumers' data, then Google has a huge advantage, can actually get away by violating your privacy way more because it can actually make more. And we'll see that on the next slide. It'll make more profit. They can sit quite far apart if they have a non-private differentiator. That's basically what we're saying. Okay. All right. So there's lots of parameters, but here's a sort of simple way to think about it. There's a revenue independent of consumers' private data. There's a consumer's valuation, and then there's this whole heterogeneity business, right? And there's all these operation costs. So here's what happens. These are all the consumers that actually pick this service provider. In fact, consumers who have a valuation of privacy that's larger don't go with this. They actually go with the one that violates their privacy more, simply because the QoS turns out to be better. And these things depend on the parameters, but that's how the space. So, Adam, you're actually making faces.
I'm just digesting. I don't understand the x-axis.
The x-axis is the normalized valuation of privacy. So this is how the normalized valuation of privacy gets broken up between the two service providers. That's what I'm saying.
So people with a lower valuation of privacy choose service provider 1.
Right.
No,
Where service provider 1 is, huh?
Lower on the scale is more private.
Liking
yes.
privacy.
Yeah.
Like in differential privacy.
Yeah, so small epsilon is very private.
But you said lower valuation
Mm-hmm.
of
Okay,
privacy.
sorry, yes.
What is
Sorry.
the x-axis?
X-axis is epsilon normalized to 1.
It's just like epsilon.
Yeah, epsilon can be any range from 0 to epsilon bar.
But like, for this entire talk, we could just set epsilon bar to be 1 and it would all make sense.
Okay, sure.
Good.
All
That
right.
way there's like fewer parameters.
Sure, okay.
All right. So now it's saying people whose relative value of privacy to QoS, like who value privacy more relative to QoS, they're at the bottom, they're at the left end, the other people at the right end, they choose, yeah, okay.
Only because we made an assumption that the whole field will be covered. Okay, all right. But the takeaways here are the following. Really, there's really 3 little takeaways. The service provider that has a large non-private revenue has a larger market share. Okay, so that's one takeaway. The other takeaway is that the competition softens if there's a very large, so this is where the epsilon bar matters. So if you want to put that away for a moment, the competition softens if consumers value privacy a lot more. So that takes you from, say, privacy to a same unit as QoS. If the T is very large, this competition is going to soften. So that's not surprising, right? And if it's very expensive for either service provider to provide you very high QoS guarantees, then the competition softens as well. So in fact, so if,
The competition is soft.
meaning you get closer and closer to one half. They will have, both will have a similar share of the market.
Sorry, does that mean that if consumers start valuing privacy a lot, that actually pushes their private option to be worse?
No, so there are multiple parameters, keeping some fixed. I'm not sure I completely understood your question. What I'm saying is that you're right. If consumers value privacy a lot, so DuckDuckGo has a better market share, keeping all other things constant.
But
For you, that
epsilon
means-
also grows.
They might even choose to offer.
Go becomes a less privacy preserving product as a result.
Maybe.
The more people like privacy, the worse the products get.
Yeah. Yes.
It's,
Yes. Or the more the cost of providing good searches, the less. And the similar thing happens here as well. If the cost of giving you a very high quality search goes up, the market softens as well. The competition softens, which is equivalent to saying, yeah, they give you very similar privacy guarantees. There's no distinction between them.
where's, there was some other parameter, lambda, which was not T. Lambda was like the quality of service to privacy conversion for the producer
Yes,
Search.
and that comes in.
somewhere else. Okay, it's okay.
Oh, it should come in here, but I'm not. Yeah. I have to remember that. Anyway, just one last point about this is that. So there's a certain amount of profit each one of these make. Yes, I'm going to be done. Thank you so much.
I made him stand up. It's not his fault.
No, I'm sorry. You know what? Quickly going into some results. It's a fair thing to do. Over parameterize. So I took a big range of epsilon. So here's the thing, right? Only this range of epsilon bar, which is your maximum risk, mattered to in this particular setting where we took these values for the parameters to have a feasible market. Meaning where every consumer who has a certain privacy choice can have a particular service provider, okay, to cover the market. And so what you're seeing here is really the market share as a function. If people get more and more tolerant, they have a bigger privacy risk. The market share for obviously service provider one goes. Oh, that's very interesting. I have to process this a little bit for my own self for a moment. There's a lot of parameters here, so even I'm losing it very quickly. Okay. I can't answer your lambda question, but I'm going to answer the T question. T is how much you value, right? So as T increases, service provider one gets a larger market share. That's basically all this is. So I'm going to stop it there. There's a lot more plots, but the big idea here is that the big or small, whatever. The idea is to ask if you could differentiate two service providers in a certain manner through privacy and QoS, but there's no price involved, and modify the hoteling model. How can you look at competition? And the idea, the only two takeaways I would ask you to think is if consumers value privacy a lot, it softens competition, and it is possible to be profitable if you have a differentiated valuation. Thank you very much.
All right. So let's